Hello everyone, and welcome back to Math Novas. Up until now, we've solved equations where the variable appeared on only one side. Today, we are going to look at equations where the variable appears on both sides. Don't let that extra variable intimidate you. Once you learn one very simple rule, these become incredibly straightforward. Let's look at our first equation. 3x plus 5 equals 2x plus 11. We can treat an entire variable term exactly like a regular number. By subtracting 2x from both sides, we move the variable terms to the left, which simplifies our equation down to x plus 5 equals 11. Now we just isolate the x by moving the constant number to the opposite side. We subtract 5 from both sides, which gives us our final answer, x equals 6. Shifting these variables and numbers across the equal sign uses the exact same logic as the basic arithmetic equations you have already mastered. Let's write down the exact rule for this process. When variables are on both sides, Step 1, bring all the variables to one side. Step 2, bring all the numbers to the other. Just remember, variables together, numbers together. Let's apply this to our second example. 4x minus 3 equals 2x plus 7. Following Step 1, we group the variables by subtracting 2x from both sides. That brings us to 2x minus 3 equals 7. For Step 2, we move the numbers. Since we have a minus 3, we do the opposite and add 3 to both sides. Now we have 2x equals 10. We divide both sides by 2 and x equals 5. Strictly following this variables first, numbers second sequence organizes the problem and helps ensure you don't miss any operational signs during the transfer. Let's pick up the pace for example 5x plus 8 equals 3x plus 18. Subtract 3x from both sides to group the variables on the left. That leaves 2x plus 8 equals 18. Subtract 8 from both sides, leaving 2x equals 10. Divide by 2 and x equals 5. We will run through this sequence one more time. Example 4 is 7x minus 4 equals 5x plus 12. Move the variable by subtracting 5x from both sides. Now we have 2x minus 4 equals 12. Add 4 to both sides to get 2x equals 16. Divide by 2 and our final answer is x equals 8. Regardless of the integers you start with, repeating this specific two-step sequence will always result in a correct isolation of the variable. Now it's your turn. Take a look at question A and question B on the board. Pause the video right here, grab some paper, and apply the two-step framework independently. Let's check your work. For question A, the steps leave you with x equals 6, and for question B, x equals 7. Solving these parallel problems ourselves is how we move from simply watching a lesson to actually building a skill. Let's summarize the workflow. First, bring all variables to one side. Second, bring all numbers to the other side. Work step by step and always check your final answer. Before we wrap up, here is your homework. Solve the equation 8x plus 5 equals 6x plus 17. Find the value of x and write your answer down before our next session. In our next lesson, we will continue our algebra series by exploring the components of algebraic expressions, including terms, coefficients, and constants. Mastering this balancing technique allows you to handle more complex equations where variables appear in multiple places. Thank you for learning with Math Novas. Keep practicing and keep growing your skills.